As you can see, it is daytime already. The clock is 5. Very nice. Today, much better. Today on the bench, some bullshit. Some real bullshit. Now, I'm not sure who is fucking me more at the moment, but let me just quote the fake JFET trap. So, what I have here is this schematic, not this one, this one. This beautiful schematic. Let me get a point of price. So, AC 50 millivolts comes in through one resistor to limit the current. A 10 microfarad filter here to get AC out. You get the 1 mega ohm input impedance bullshit. You get some more protection diodes. That's the positive side of this. Then the negative side has the 100k focus, you fuck, 100k to 1k divider, so that I get 100 gain of 101. This capacitor here so that I don't have DC at the output of this op amp. As you can see, this circuit works. This circuit, on the other hand, which is the exact same thing, TL061CP, as in CP, doesn't. And why? Because as you can see here, there is no ground reference point for this. To be able to get a ground reference, there is no middle point. Like the 1 meg is too big, and this one isn't. Supposedly it's a fake chip. When you short out this cap, as you can see with this wire, I first tried the resistor, but now I just do the wire. It works. It does squeaky squeak. The point of this device was to hold on, let me not. Was to build a simple signal tracer, mainly for popcorn noise from Zener. As you can read, all diodes are 1 and 48, 41, 48. This works. You just have to short out that cap right there. Now, is the gain 101? That's also a good question. Fuck if I know. I'm inputting 10 millivolts and I am having difficulty measuring the output. But it's clearly audible, as you can tell. Oh, sorry for anybody having tinnitus. There you go. Much better. Situs, whatever the fuck it's called. What's it called? The pussy telephone. Anyways. But why are we doing this? Is because we are repairing. There we go. We are repairing a Weston multimeter from the 70s, basically early 70s, and the motherfucker keeps drifting and drifting and drifting. Let's go with the OCR version. Model 1242. Let me show you the good looks it has. It's got Nixie tubes. Here you go. It's got Nixie tubes. It's got all of these fucking switches, which are cursed. This switch, which is semi-cursed. The input jacks, which are like cursed AF. But this will be in a separate video. Point of this video is to show you the build. The build, as you can see, is inside a battery pack box from a battery. These are two batteries in series. I get the middle point to power the circuit. I use it, and then I have bipolar power for the op-amp. Quite simple. I got this shitty charging circuit here. I just put a boost converter, a diode, and the battery. Just I charge. It's not the right way to charge it, but I don't give a fuck. This is supposed to be a one-time use device, but I did put a BNC on the front so that I can probe the Zener diode in the circuit. Let's go. Welcome to my hell. This motherfucker is the bullshit. Okay, Adobe is fucking ugly as well. Try the new intuitive Acrobat. No, I pirated this. Let's see. So, a 6.32 volt reference and a 6.2 minus volt reference, or minus and plus, whatever, it doesn't matter. Create this circuit which fills and empties this capacitor here exactly according to the gods who invented the device in question. Fucking disgusting piece of shit which I spent the past 2 weeks working on. Anyways, the current reference needs to pump in 900 microamps and pull out 100 microamps. However, since microamps is not a measurement device for measuring charge, it's for measuring current, because fuck you, that's why. This I have been suspecting on noise in my references and noise in my plus and minus 12 volt rails, but nothing shows up on an oscilloscope, so I've made this device, this piece of shit, so that I can listen in. I'm using an op-amp to boost the signal, and then I'm driving it into this little Bluetooth speaker because it's a power speaker, and I had to have a power speaker because this has terrible impedance. So it has to go into a high impedance device, which will then turn it into a speaker. As you can tell, it's quite loud by the tape. And let's try using it. Here I have my bench power supply that I made a few years ago, like 10. I know that this motherfucker has 50 Hz hum on it when I go above the, the rail that the output can achieve, because my transformer is a bit wrong. Oh, for fuck's sakes, I need to plug it in. Of course, I'll be right back. I'm back. I spent the past 15 minutes trying to measure this degree of amplification, but it seems to be impossible. Let's listen in then. Let's listen to my multimeter. So, since this is a fluke, no sound. It has an electrician's multimeter, so it's got an low impedance mode. But at low impedance, the inputs might as well be shorted. I'm just using a oscilloscope probe set to 1x, and that's it. That's my probe. That's why I put a BNC on there, because it's shielded. I didn't want to bother with shielding. So now then, when we switch to the high impedance modes, like the amps, fuck you, volts, it's all good. But when we go to resistances, it's not very happy. Did you hear the click? That's what I'm looking for. And you can hear the charging and discharging when in capacitance mode. So that's neat. We can listen to a lot of things. Let's see what else we can find. The woo of this soldering, I don't know. Probably can hear this clock. The loudest part should be here, because this is where the transformer is. Yeah. Here you can hear the switching. That's cool. You probably hear the monitor as well. Or not. Ah well. Good enough. Let's see what's next. The keyboard. Multiplexing and shit. Okay, we are connected to the power supply. It's currently off. Turn it on. And we get silence. 3 volts. When we go all the way on the amps range, this is a fault of the design, so it pushes the current away, or pushes, yeah, and then it just goes. But now you can hear it, it's completely audible. Anyways, what I wanted to show, there you go. Again. This motherfucker fucking out of regulation at exactly this point. Here it starts to hum. You can hear it. That's pretty cool. Let me think. Also, the absolute silence from the output of this calibrator. However, this calibrator is faulty as well. So let's try to switch to volts. What the fuck was it? Mod? Tip? No. Milliamps, volts. Does that do anything? Millivolts, milliamps. Oh yeah, it does. It does a clickety click. Because it's shitty. Oh, you can't hear shit. This motherfucker's so silent. I mean, it's a calibrator. Still, how about some hum? Something. Nothing. Damn. Good thing I stole this motherfucker. Otherwise it would have gone to the trash. Let's see. I know. Let me show you this lamp. Sorry. This lamp. I haven't made a video on the lamp yet, but I made this like 3 years ago or something. And it has currently 24 volt bulbs, whilst it was originally designed for B cells and shit, so I think it's written here charged 2022, so it's been 4 years. 43 microamps since then, right? So 4 years since this was charged. Let's see if it works. That's one light and the other light. So I made this modification to it. 2 diodes to measure the voltage drop, and then to turn on and off this PNP, which I bodged onto here so that it turns off the converter when it's off, when there is no load. So 2022. Let's listen in. Sadly the battery went on the little speaker, so it's plugged into the wall and it's making its own noise. Oh, I could short out here. Yeah, okay. But even this little contact noise here, you can hear it scratching. It's so fucking good. Anyways, let's try to listen on the lamp. This being a battery powered circuit, it's completely silent. Only thing you can hear is a little pop. I can't even see the pops, but I can hear them. And I know that there is contact bounce here, like I put solder on it. Come on. I put solder on it and stuff. It's definitely got bounce. Anyways, let's listen in on a different part of it. Nah, it's very quiet, you can't hear shit. I thought you could hear the switching frequency. Or this, it's squealing It does squeal when it's shorted out, but then again, who wouldn't? Anyways, what? Almost fell. Amazing. That was about it. This is how AI will fuck you. This is how AI will fuck you, bro. Like, this works. If you have an original nice JFET, doesn't work with every op-amp. No. You wanted this op-amp? Now you got this op-amp. And you aren't paying for Pro? Fuck you too. Have a nice day. Bye.